All right, let's picture this. You're sitting at your laptop and you need to get onto a company server. You're on the network, sure, but it's a huge network. How do you actually prove who you are without basically shouting your password across a crowded digital room where, let's be honest, anyone could be listening? That is the exact problem we're going to tackle.
And yeah, that challenge, proving you're you when you can't really trust the space you're in, is exactly what a protocol cooked up at MIT back in the 80s was designed to solve. It's all about creating trust in an environment that has none.
So the question really just boils down to this. If sending your password is a huge no-no, I mean, way too risky, how does a server on the other end ever truly know it's you? This is the fundamental dilemma of network authentication.
You know, the old way is kind of like sending your house key through the regular mail every single time you want to unlock your front door. It just feels wrong, right? It's way too risky. Kerberos has a totally different approach. Instead of that master key, what if you could get a temporary, single-use key for a specific door at a specific time? That's what it calls a ticket. This whole ticket-based system is called Kerberos. And yep, if that name sounds familiar, it's named after Cerberus, the mythical three-headed dog that guarded the gates of the underworld. It was developed at MIT to, well, guard network services. It's meant to be this central trusted gatekeeper for an entire digital kingdom.
And that really is the core concept here. Instead of every person and every server trying to figure out who to trust on their own, they all just agree to trust one central authority. This trusted third party knows everyone's secrets, and it uses some clever cryptography to basically act as a broker, making secure introductions. To really get our heads around this, let's use an analogy. Think of a giant fairground. In this scenario, you are the client, you're the fairgoer, and you're there to have a good time and get on all the cool rides. And the rides themselves, the Ferris wheel, the roller coaster, those are the services. In the real world, these are the resources you want to use, like a file server, a particular app, or maybe a network printer. So you want to go on the rides, you need tickets. Where do you get them? Well, from the main ticket office, of course. In the world of Kerberos, this is called the Key Distribution Center, or KDC for short, and it is the absolute heart of the whole system. It's the one place you go to prove who you are and get all the tickets you're going to need for the day. Now, this main ticket office is so busy, it has two different windows. The first window is the authentication server, or AS. Think of this like the main gate to the fairground, where you show your ID just once to get an all-day pass. The second window is the ticket granting server, or TGS. This is more like the little ticket stand next to a specific ride, where you show your all-day pass to get a ticket for that one ride. Okay, so we've met all the players in our fairground. Now, let's actually see how this whole thing works. It's really like a three-step dance, a back and forth of exchanging tickets to get where you want to go securely.
So high level, it's pretty simple. First, you prove you're you to get your main credential. That's your all-day pass. Then you use that pass to ask for specific ride tickets. And finally, you give that ride ticket to the ride operator. Seems straightforward, right? Well, let's look a little closer at what's really going on. So for step one, your computer sends a request to the authentication server. But here's the really clever bit. You don't actually send your password. The AS already knows a version of your password, a hash of it. It sends back a message that's encrypted using that password hash as the key. So if your machine can successfully decrypt it, that proves you know the password without ever having sent it over the network. And boom, success. You now have a special ticket called a ticket granting ticket, or TGT. This is your all-day pass. Now for step two. Let's say you want to get to a file server. You take your TGT, your all-day pass, over to the ticket granting server, and you say, hey, I'd like a ticket for the file server, please. The TGS looks at your TGT, confirms it's legit, and then issues you a brand new, specific ticket just for that file server. Now notice what didn't happen. Your password was not used at all in this step. And finally, you walk right up to the file server, the ride itself, and you present your service ticket. The server can decrypt this ticket because it shares its own secret key with the KDC. This proves to the server that you're the real deal. But here's the real magic. The server then sends a confirmation back to you, which proves its identity to you. This is called mutual authentication. You both know for sure that you're talking to the genuine article. No imposters.
So that's the fairground analogy. But this isn't just some abstract idea from a computer science class. Kerberos is silently humming away at the core of so many of the networks you probably use every single day. Now, the protocol's been around for a while. Version 4 popped up in the late 80s, but it relied on an encryption method called Ds,
which, well, it's considered pretty weak by today's standards. The really crucial update was version 5, which came out in '93 and was updated again in 2005. It added support for modern, heavy-duty encryption like AES. That's a huge reason why it's still trusted today.
And I bet you've used it without even realizing it. I mean, if you've logged into a Windows computer on a work or school network anytime since the year 2000, you've used Kerberos. It's just the default. It's also built right into macOS and Linux, and it's the invisible engine behind a lot of those single sign-on systems that let you log in just once to get access to everything you need for the day. But it does have a pretty famous Achilles heel: time. See, every single ticket Kerberos issues has a timestamp on it. This is to stop an attacker from, say, grabbing an old ticket and trying to reuse it later. But for this to work, all the computers on the network, your laptop, the servers, all of them, have to have their clocks synchronized, usually within about 5 minutes of each other. If the time's off by too much, authentication just flat out fails. So let's kind of sum that up. The pros are really powerful. Your password never travels across the network, it uses rock-solid cryptography, and you get that awesome mutual authentication. You know who you're talking to, and they know who they're talking to. But the cons, they're pretty significant. That KDC is a single point of failure. If it goes down, nobody can log into anything. And like we just said, it is incredibly picky about time.
So after all of that, let's just bring it right back to the core principle here, the fundamental reason this whole protocol has been so successful for so long.
If you remember one thing from all of this, let it be this: trade tickets, not passwords. Your password is your master key. You want to protect it and use it as little as possible. Tickets, on the other hand, are temporary, they're disposable, they limit your risk. This whole elegant system, this entire fairground of tickets and ticket booths and rides, it's all built on that one powerful idea: having a central, trusted authority broker every single interaction. By issuing these short-lived, single-purpose credentials, it centralizes all the trust in one place, so the rest of the network doesn't have to worry about it.
And that kind of leaves us with a final question. You see, Kerberos was designed for a world where you could draw a nice, neat line around your network and trust a central gatekeeper inside. But today, we're all moving towards zero-trust networks, where the whole philosophy is to trust nothing and verify everything all the time. So the question becomes, can this three-headed guard dog from the 1980s still protect the gates of a totally different modern internet?